All right, so what I want to do is talk about properties of exponents. I like to do this before I multiply polynomials because what we really need is the product rule when we are multiplying with polynomials. So I just do a little lesson on the entire properties of exponents before just to get that covered. So looking at the properties, and some of you might be familiar with these, so I'm just going to kind of go through them pretty quickly. So when you're multiplying with powers, what you do is you add the exponents. So you can see that here, so if you have a to the m times a to the n, you're actually going to add those exponents. It's probably easier to look at it as an example here where you have some terms to go ahead and multiply instead of just using the general form. So if I have x squared times x to the fifth, you can see we add that and that gives us x to the seventh. Looking at the quotient rule, when you are dividing with powers, you subtract the exponents. So notice that I'm going to go right to the example here. If you have x to the eighth divided by x to the fifth, you are subtracting the top, so the 8 here, get a highlighter, minus the bottom number. So it's x to the 8 minus 5, which is equal to x to the third. Now notice we're doing that in the numerator. So this is not 1 over x to the third, it is x to the third. Then you have your power rule, and broke that up into two power rules. One, because if you look at this first example here, which is this, you have basically a power being raised to another power, so an exponent being raised to another exponent. When you do that, you're going to multiply these two numbers. So that becomes x to the 3 times 5, which is equal to x to the 15th. The difference with the second power rule is that you have a product inside being raised to an exponent. So you can see the difference with this example here. In the previous example, it was just one term being raised to an exponent. Here, it's one term, but there's a multiplication in there. So what we need to do is basically distribute that exponent to both the coefficient and then the variable there because it's a multiplication. Remember, there's a little multiplication symbol in there. You just don't see it because the numbers are right next to each other. So then this becomes 7 squared times x squared, which then of course becomes 49 squared. So that's a little different than the problem that we did before because it was just an x here in the previous problem. It was just an x, there was no multiplication or division, so we were just multiplying by the exponent of the 3 there. Now, I always point this out, don't get confused if you have something like this. Students make this mistake all the time. If you have x minus 2 squared, you cannot use this power rule. It doesn't apply because you don't have a multiplication or a division in here. This is a subtraction. So you cannot distribute this 2 to both these terms. So this does not equal x squared minus 4 or x squared plus 4 if students are squaring the minus sign. That is just not true. And it's a common mistake. We see it all the time when students are working and they're actually multiplying binomials because it's squared. So just pay a little attention to that. Be careful with that. You have to have a division or multiplication in order to distribute that. All right, looking at the negative exponent, and broke this again down into 2 because here you can have the negative exponent that's in the numerator. So this term right here is technically in the numerator. It's basically over 1. So what you do is you flip it and it goes to the bottom. So then that's equal to 1 over a to the m. Again, it's probably easier to look at an actual problem here. So if you have x to the negative 4, you flip that and it goes to the bottom, which then gives us 1 over x to the 4th. And then I broke up this problem here to another rule as a negative exponent rule part 2, because if you already start off, and I'm just going to go right to the example, if you already start off with the negative in the denominator, so if it's already in the denominator, you're not flipping it to the denominator, so basically this gets flipped back up and you wind up with x to the third. So make sure you pay attention to where that negative exponent is. Is it already in the numerator, like here? Or is it in a denominator, like here? All right, and then the last term, sorry, the last rule we have there is just anything to the 0 power is equal to 1 except 0. So anything you see I have 4 to the 0, that's equal to 1, or if I take some other term here, I got 9x being raised to 0, it's still going to equal to 1. So the only thing that is 0 raised to the 0 power, that's just undefined. I know there's arguments about whether it has a value or not, but for our purposes, 0 to 0 power is just undefined. All right, so then the next lesson, what I'll do, or the next video, is I'm going to probably do some of these, use these properties and simplify some of the problems. I don't want to combine it all into one video because it would be too long. So in the next video, I'm going to just go over some of the problems.